Couple of words that go along with the function notation. We could apply them in other ways, but you really see it with the function notation, are domain and range. Now, domain is essentially tells you about the input, right? So the input is the domain, and generally, unless there's something else messing around, you assume your domain is such that you can put in any real number. However, there are times in which you might limit it. So for absolutely no reason whatsoever, other than to just illustrate it, let me say that our domain can only be 1, 2, 3, or 4. Now here, of course, it's by function, where I'm multiplying by 2 and adding 5. So 1 would turn to 7, 2 would turn to 9, 3 would turn to 11, and 4 would turn to 13. Now the output here, the range of output that you get based on the domain, is called, with amazing subtlety, the range. Okay, domain is your range of input. Range is the range of output. That probably wasn't the best way to phrase it, right? Domain tells you about your input. It can be unlimited or it can be limited for whatever reason. And range is the output that you get for a particular function based upon what goes in the domain. Now, here's a couple of examples for you. Function f of x is 6x minus 2, has domain 0, 1, 2, 3, 4. What's the range? So we'll set up our domain 0, 1, 2, 3, 4, just apply the function. So 6x minus 2, well, if x is 0, 6x minus 2 is minus 2. If x is 1, 6x is 6, minus 2 is 4, etc. And so we do that calculation, minus 2, 4, 10, 16, 22, and we would say that our range associated with this domain, minus 2, 4, 10, 16, and 22. Notice that I'm putting both the domain and the range in these little curly brackets there. So in the last examples, I limited the domain artificially and thus limited the range. However, there are times in which the function will itself dictate that maybe the range is limited or maybe the domain is limited. For example, think about g of x is x squared plus 3. I'm going to say the domain is all real numbers. What's the range? Well, you might say, well, all real numbers. Except, of course, when we look at this function here, x squared has to be positive. Okay, if x is 0, well then x squared is 0, but if x is minus 1, well then x squared is 1. If x is minus 10, x squared is 100, and so on. So x squared must be positive, okay? And indeed, more than that, x squared has to be at least 0. So therefore, x squared plus 3 has a range such that all real numbers greater than or equal to 3, okay? Because if doesn't matter what you stick in for x, you're never going to get anything less than 3. 0 for x would give you 3, thus greater than or equal to 3. But then after that, any value of x gives you a positive x squared, which therefore has to give you a number greater than 3. So the nature of the function can actually limit the range. And then there's also going to be some times in which the domain itself is limited. For example, I could say here function g of x is 3 over x minus 2, has domain all real numbers. Trouble is, look at that bottom bit there. If x is 2, 2 minus 2 is 0, dividing by 0 is infinity or not defined, however you might want to say it. Regardless, whatever you do, x cannot be 2. That is excluded from the domain if you're looking at some particular function like this. And same idea, let's use that silly new notation, function h, such that h goes to the square root of x minus 4. So I tell you, well, it has domain all real numbers, except, of course, that x minus 4 has to be greater than 0 because you can't take the square root of a negative number. Okay, so in that case, we've got a massive limit on the domain. X has to be greater than or equal to 4 because if this is a negative number, you can't do it. Okay, so domain and range, you can artificially limit the domain, which will artificially limit the range, or the possible things that can be in the domain or the possible range can be limited by the function itself.